Hey everyone, good morning. Today let's solve the Leetcode daily, which says number of unix or triplets too. Let me, I haven't solved it before. Let me reset the timer and start the stopwatch. Let's go. You are given an integer array nums. The XOR is defined by a XOR of three elements ijk, and they are less than or equals to number of unix or triplets from all possible ijk. So basically, we are given an array nums. We need to traverse through all the triplets in the nums such that ijk are index of triplets and I and jk are in a equals to or greater than order. Now we need to return unix or triplet values possible. Let me take example of this 1 comma 3. Here we don't have three values to have different ijk. So possible values are I, j, k are equal, or any of those I, j or k, any two of those are equal. Here if you see I, j, k is same and equals to 0, and I, j are same equals to 0, and j, k are same equals to 1, and I, j, k are same equals to 1. So 1s are 1 is 1, 1s are 1s are 3 is 3, 1s are 3s are 3 is 1, 3s are 3s are 3 is 3. Mm. Now if you look at this, if you take two values same and one value different, then obvious the end will be the different value. And even if you take three values same, the XOR will be the same value. So you will definitely get all values from num. This is one observation. Now you need to check like if there are any new values possible. Obviously, like if we are selecting three numbers, there will be a new XOR. But how do you find that? So you can do recursion, taking one element, taking next, and taking next I, taking j, taking k, and you can find all the possibilities. It would be an approximate of 3 power n combinations, or you can think of nc3 ways. Out of n length nums, you are taking every combination of size 3, so it's nc3. Wait, order is maintained, so it's np3 not nc3. Yeah, now doing np3 for 1500. 1500 factorial, it's too much, so we need to come up with optimal one. Now if you take this recursive pattern, you can see there is overlap. So we have I, j, and we have different k values. Now for the same I comma j, we already know the XOR. Now the remaining thing we need to check is k value. Now if we get XOR of I comma j, to find k value with uh to find XOR with k. Okay, this is interesting. Mm, 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 mm. Is there any bitmap pattern here? define triplets. Ones or threes or five will be like the maximum bits of three numbers. Is that true? No, it's not true. A's or B's or B. XOR in the sense if there are 0 and 1, it will become 1. 0 and 0 will become 1. 1 and 1 will become 1, 0. 0, 0 will become 0. 1, 1 will become 0. Uh, 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 uh. So in this case, what will be the result? And key thing is you need to find unique XOR values. Can we use map to XOR? 2 XOR 3 is 5. 5 XOR 3 will be 2. If I take 3 triplets, right? If I take 3 triplets, if I get I XOR K, XOR K. If I XOR J is already no IJK. Let me think. I think that's the only way we are having. Is there any other way? Not getting. If I have IJ and K, do we need to check uh, 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 all the elements? I have one set to check, and I have another set to check the XOR. So I'll have number XOR previous stack and yeah, I think that's the only way we are having. We need 3 sets. One set store previous values, previous and num values. Another set, second set I need it for storing the XOR values, XOR of current and previous. Third set, do I need any other set here? Yeah, I need third set from second set, again do XOR. with num. Yeah, I think this makes sense. The complexity is so often we're only traversing one space is so often plus n plus n because of three sets. Hmm. Let's go. Da, 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 da. First set, let me take as set of int 1, set of int 2, set of int. Third one will be the result, right? That we need to return. Now for int num in nums, I just add the num to 1, push insert of num. Yeah, now for int x in 1, I need to insert XOR num XOR num into. Now I got j. Now the thing is k. From 2 I need to insert in result. For x into result dot insert of x XOR num. Now return result dot size. Let me run. Yeah, it got passed. I don't think any better approach is there. Let me check if it is. Oh, it's giving me chili. Why though? Uh, 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 why chili? Why? Uh, mm, 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 mm. Why there is issue with this? Uh, uh, uh. We are having three sets, and we are just adding it so often. Why? Let me take another set, right? Better. Third set 1, 2 result. Let me check if things are passing. Let me use this test case. It passed. Let me submit. Okay, this got passed. So the issue is like when we use set, it is like a red flag tree, and it takes off login to insert and check. While if we use unordered set, on average it takes off one to insert an element and find the element. Let's see if there is any better approach. Start size max u is 1, u less than or equals to max. We are incrementing to power is of u. Okay, Okay. Hmm. But uh, okay, okay, got it. I'm just understanding the intent here. Wait, I'm thinking this is map approach. Like, if we do XOR of like triplets, what will be the XOR? Mm, mm, If we are only having two, then we are having only triplets as the given, so we just return two there. Even if we have one, we just return one. The triplets come into picture when we are having at least three elements. Suppose we generate every possible jar. Maximum value is wait. I think both are same complexity. It is also often square, and even if we compute all the like XORs and check in the map set or like any map, even it is often square. So I don't think uh yeah, I think this is better Bitmas solution. Let's go with it.